Today we're moving on to the second half of Chapter 7. This is operation with radical expression. So today we're going to go through some properties of radicals and how you can multiply, divide, add and subtract radical expressions. Very similar to other things, we're just going to kind of go through them with radicals. So the first thing is if you have two things that are being multiplied underneath a radical, you can actually separate that into a separate multiplication problem. Same thing with division. If you have two things that are under the same root, you can separate those so it's two separate radicals. You can have, for instance, if you have the square root of 2/7, you could have the square root of 2 over the square root of 7. Then there's the process called rationalizing the denominator. So this is something that we've mentioned before, you guys should have talked about before at some point. What it is you're looking at, you don't want to end up with a radical in the denominator. That's improper in terms of mathematics. So when we look at this, we have the square root of 3 over 5. That translates into the square root of 3 over the square root of 5. Well, in order to get rid of that, I'm going to multiply by whatever the denominator is over itself. So since the denominator is the square root of 5, I'm going to multiply by the square root of 5 over the square root of 5. Because that is equal to 1. And in the denominator, the square root of 5 times the square root of 5 is 5. The square roots cancel, so I eliminate the radical in the denominator. And then we have the square root of 3 times the square root of 5, which you can combine to just be the square root of 15. So let's take a look first at some of these examples. And the first one we're going to look at is the square root of 16 p to the 8th q to the 7th. And this is, I've showed some of you this already, but we're going to look at this again. The square root of 6, so really what we're looking at here is the square root of 16 times the square root of p to the 8th times the square root of q to the 7th. The square root of 16 is 4. Square root of p to the 8th, remember you divide that exponent by whatever the root is, which is 2, so it's p to the 4th. Now this one we're going to need to separate. I can separate this into the square root of q to the 6th times q. So you separate it so that you have 1 left over and then you have an even. So the square root of q to the 6th is just q to the 3rd. And then we have the square root of q left over. So your answer is 4p to the 4th q cubed times the square root of q. In this one I can separate to be the square root of x to the 4th over the square root of y to the 5th. When I do that, the square root of x to the 4th, we divide it out, we get x squared. Now this one, remember, we have to separate because 5 is not divisible by 2, so I have to make that y to the 4th times y. Then we have x squared over y squared times the square root of y. But I'm left with a square root in the denominator. So now I'm going to come down and I'm going to rationalize this. So we have x squared, I'm just going to rewrite this really fast. How do I rationalize this? Only the part that's in a radical. The y squared is fine. I'm just going to multiply by the square root of y over the square root of y. So in the numerator, we're left with x squared times the square root of y. In the denominator, square root of y times square root of y is just y times y squared becomes y cubed. So very similar thing's going to happen with letter C over here. When I separate this, we're going to get the square root of 5 over the square root of 4a. Square root of 5, nothing can happen with. All of the square root of 4 is 2, and then we're left with the square root of a. I can't be left with the square root of a. That's a radical in the denominator. So I'm going to multiply this by the square root of a over the square root of a. not the 2. The 2 can stay, just the square root of a. So in the top, that becomes the square root of 5a. You can combine them under one radical, and this is just going to become 2a. Those do not simplify. One is in the radical, one is out of the radical. So you cannot simplify them over the top and bottom unless they are both under a radical. The other important thing to note is that with these ones, we want to make sure first off, before we do anything else, that we are in the same root. We can't do any of these properties if we have the two different roots of a couple of different things. So with these ones, we want to make sure that we're dealing with the same root in both of them, which we are. The first one's dealing with the cube root, the second one's dealing with the fourth root. So that's our first question. Now we want to look at if we can recombine, and we can combine some of these things under one radical, because the cube root of 9, that isn't anything. So when I multiply these, we multiply the coefficients on the outside. 6 times 3 is 18. And then we have the cube root of 9n squared times the cube root of 24n. So 9 times 24, we can do that. And then we'll also have n squared times n, which will just be n cubed. So we grab a calculator and we can do 24 times 9. Which gives us 216. So now we're asking ourselves, what's the cube root of 216? Or is there a factor of 216 that is a perfect cube? So if we start by testing, we'll just say, what is the cube root of 216? It gives us 6. So it in itself is a perfect cube. So then we end up with 18 times 6. The cube root of n is n, or n cubed is n. So then we do 18 times 6. Let's see, gives us 48. Gives us 108 n. So we are able to actually simplify those down to just this because we combined the two things there. Same thing over here. We have the fourth root in both of them, so 5 times 4 is 20. And then we'll have the fourth root of 24 times 54, which is 1296. X to the fourth. So I just multiplied things around underneath. So now we need to ask ourselves, is 1296 a perfect fourth? It is. Again, it's 6. So then we'll have 6x, which this all then gives us 120x. Then looking at adding and subtracting. Just like with variables, in order for us to add and subtract, we have to have the exact same radical to the same root and everything. So these are all square roots, so we're okay there. But we can't add 12, 27, and 48 because they're different. So we need to be able to get those all into the same number. So what I do is I factor this down. I'm going to say this is going to be 2 times the square root of 4 times 3, because 4 is a perfect square, minus 3 times the square root of 9 times 3. 9 is a perfect square. plus 2 times the square root of 16 times 3. 16 is a perfect square. The square root of 4 is 2. 2 times 2 is 4. So I have 4 square roots of 3 minus the square root of 9 is 3 times 3 is 9, so it's minus 9 square root of 3. Square root of 16 is 4 times 2 is 8. 8 square roots of 3. Now I have square root of 3 in all of them. Now I can add them. So 4 minus 9 is negative 5, plus 8 is 3. And the square root of 3 stays the same, just like a variable. If you have 4x minus 9x plus 8x, you get 3x. Same thing here. Alright, let's look at the next one. So how can I factor 8 so that it's a perfect square times something? Well, 4 times 2. 32 breaks down into 16 times 2. Minus 4 times 18 breaks down into 9 times 2. Square root of 4 is 2, times 3 is 6, square root of 2. Plus 16, the square root of that is 4, times 5 is 20. Square roots of 2. Square root of 9 is 3, times 4 is going to be negative 12 square roots of 2. So then we have 6 plus 20 is 26, minus 12 is going to give us 14 square roots of 2. Our next example comes with FOILing. So this is where we're going to multiply radicals. So we're still multiplying radicals, so the same rules apply as before. The only thing here is we're also potentially going to be adding them at the end. So when I FOIL, we have 3 square roots of 5 times 2. I can multiply that. 2 times 3 is 6. So I have 6 square roots of 5. So that's first. Outside, 3 square roots of 5 times the square root of 3 gives me 3 square root of 15. Inside gives me 4 square root of 3. Lasts, negative 2, square root of 3 times the square root of 3 is just 3. So none of these can be combined. Even though these two have factors that are in here, we cannot isolate this at all. So these have to stay the same. The only thing we can simplify is that. So we have 6 square root of 5 plus 3 square root of 15 plus 4 square root of 3 minus 6. That is your final answer. There is no way to combine the square root of 5, square root of 15, and the square root of 3. Let's go ahead and try this one. Notice difference of squares. Same thing, just of different signs. So 5 square root of 3 times 5 square root of 3. 5 times 5 is 25. Square root of 3 times the square root of 3 is just 3. Outsides, 6 times 5 is 30. So we have 30 square root of 3. Insides is a negative 30 square root of 3. So those are actually going to cancel. And then negative 6 times 6 is a negative 36. So then we end up with 75 minus 36. It's going to give us a positive 39. So that would actually simplify down completely without any radicals. That might happen sometimes. Alright, the last thing we have to do here is what happens when you want to rationalize the denominator, but we have something added to it. Very similar to the I values. Very similar to when we had i's. We're going to use a conjugate. So this one I'm going to multiply by whatever's in the denominator, just the opposite sign. So I'm going to multiply by 5 minus the square root of 3. But I have to do it on both top and bottom. So I FOIL. I have this times this, and this times this. So 1 times 5 is 5. 1 times negative square root of 3 is a negative square root of 3. These two give me negative 5 square root of 3. And then the square root of 3 times the negative square root of 3 is going to be positive 3. All over 5 times 5 is 25. Notice difference of squares, so the insides and outsides will cancel, and we'll just be left with minus 3. We write that. We have 5 plus 3 is 8. Minus and minus gives me a minus 6 square root of 3. All over 25 minus 3 is 22. Now we can simplify. We cannot simplify the radical. Just like the quadratic formula. The only way I can simplify is these three whole numbers here. They can all divide by 2. So we get 4 minus 3 square root of 3 all over 11. And that's our final answer. Alright, your homework tonight is on page 413, 18 through 34, the evens. Make sure you show all of your work on these problems, and I'll remind you in class, but be sure you're showing all of your work, because we're out of the point where you should just be giving me answers. These are problems where we need to make sure we're showing our work.